So the plan for today is first, let me say a couple of things about the feedback session on Wednesday. Then we will start talking about design principle, and then in the rest of the course we also see visual design, design guidelines, design pattern, everything that will help you to design the user interface, design the user experience in the various level of prototypes. And we start today with design principle, which are a little bit abstract, but still helpful for the first prototyping phase that we will start next week. And then in the second hour, we will do an exercise on tasks and storyboards. That was a topic of last Monday, because that will be the first part of assignment 2 that I will present next Monday, and will start Wednesday of next week. Okay? So first, how the feedback session will work on Wednesday. So on Wednesday, we have 4.5 hours of feedback session, all teams, all groups in parallel, which means that in the room that we have, the 3 teachers will be sit down in 3 different spots, and we will see each group one at a time for the entire duration of the labs hour, so for the entire 4.5 hours. We will publish a schedule so that each group will know when is their time. And we have 11 groups in the first and the third slot, and 12 in my slot. So it will be around 20 minutes per group. And in these 15-20 minutes, we will go through the slides. So the slides you will need to deliver, to submit, is for that session to have something to scroll through and talk with you with elements in the screen. So the quality of the slide, the beauty of the slide is not really relevant. Also because it's a feedback session and you will not be graded on that. So especially on the slide in that moment. So feedback is there, so slides are there for helping the discussion, for our support for the discussion. That's why all the questions should be in the slide, so that we open a document, a PDF document, and we go through the slides and go through all of them without all the details, because if there is something unclear, we can ask you. If something is unclear, if something we don't understand, we can ask you and you can reply. So in the slide, there should be the material that is asked to be there in the end of assignment 1 and are there to facilitate the conversation. We choose slide, not a report of 10 pages, because if we go through a 10-page report in 20 minutes, we will never end. Slides are quicker to scan through, and also we can, like for the groups that had multiple, maybe iteration on the questions, we can go faster on the slides about the questions and continue with other parts. But still, having the question help us also to help you also to make a link between the need and the questions that generates, that stand behind that need that you write. So all the pieces are there to facilitate the discussion. Again, the message is slides are there as material to support the discussion, not to replace it, not to read it from top to bottom. We will use them in discussing with you in those 20 minutes. And in doing the schedule, we will also consider your preferences from the slot allocation. So if you preferred, or if you said that you can only attend the slot number 1, you will be, as much as possible, put in slot number 1 in the first hour for the discussion. So that if you have other classes, you can go to other classes after, or vice versa. If you have other classes before, you will not have the group presenting in the first in the first slot, because you have other classes in that moment, you will be in the second or in the third time slot. Okay? And we will publish the schedule tomorrow, I think. Not today. Today is too late now. Tomorrow, so that you know in which 20 minutes you are, and you can come in the classroom when it's time for you to discuss. You can also come and stay there. Doesn't matter, but you will have a allocated slot of 20 minutes in which each of us, the teacher of your slot, will talk with the group. Okay? Any question on this? Good. So slides, again, should be clear enough to be understood, but you are there so you can complement, if needed, with your words. But one document one more visual document allows us to be quicker in giving feedback and going through all the slides as needed. And that's also why there is not a minimum, maximum number of slides, there is no template, etc., because it's a mean for communicating and for discussing. Okay, so if there are no questions on the feedback session, let's move to design principle. That is, in a way, a bit of theoretical lecture. There will be examples we will discuss, but this builds the foundation for you to then design your first prototype that will be in low fidelity. So there will be no colors, no font choice, no all these kind of things. So we cannot give you, it doesn't make sense to give you information about visual design in terms of colors, because they will not be. We will give you before you proceed to that level of fidelity for the prototype. So we need to stay a little bit in the more abstract but principled thing to do. But let's start, as always, with the Hall of Fame, Hall of Shame. So this is a page in a end of a shopping in which the owner of this website asks you to recommend the service, the vendor, on a scale of 0 to 10, where 0 is extremely unlikely and 10 is extremely likely, and then there is a scale in the middle. So this is more Hall of Fame or Hall of Shame, and which are the problem in this picture, if there are. Okay, who say more shame? Who say more fame? Why more fame?
Well, I think it's clear.
Bo is a nice start. Okay, without Bo, you think it's clear. What is clear?
There is the colors from red.
Mm-hmm. Yeah.
The shape of
The faces, the smile, so is sad, is a little bit less sad, and is neutral, and then is happy. Mm-hmm. Yeah, that's just positive things that are true. You don't see any problem. Let's hear someone that say shame. Why shame?
Number one, there are 11 values, and that triggers me, because why not 10 but 11? And number two, the faces are not proportioned, because from until 6 they're very sad.
That's the problem of this. Well, they trigger you 10, but it's 11. Sorry, because I think they wanted to make it like, well, we can discuss whether it would be better to start from 1 and then to 11 if you want a number, not like to have a neutral answer. It could be like 1 to 5 as well, or 1 to 7, whatever. But the problem here, the big problem here, is that colors and emoticon and expression are not fair. So these are like a deceptive design pattern in a way, because which are the score that are positive if you look at this. 9 and 10, but actually 6, 7, 8, 9, 10, or 5 also, because start from 0, is on the positive side. But instead, 5 and 6 are depicted as negative, and 7 and 8 as neutral, and 9 and 10 as positive. So the question is reasonable, the scale could be refined, but more or less is reasonable. It's clear, of course. There are colors, there are emoticons that also express that sense, perfect. But then, big failure is why only 2 are positive and like 7 are negative and 2 are neutral. There should be more balance. So here, this is called, well, you will see this when we talk about design patterns. This is a deceptive pattern, also known as dark pattern, because it gives you a nudge towards replying on the green, on the 9 and 10, as if only 9 and 10 are positive score, but in a number, also 6 is quite a lot likely. It's not extreme likely, but also 6 is likely, but the face and the color doesn't give you the same sense. So this could be a bad example not to replicate, because it's trying to persuade that 9 and 10 are the right answer, but actually all the others are still positive. Also 7 is positive, 8 is positive, it's not neutral. Neutral should be 4 and 5, which are in the middle, or 5 and 6, which are in the middle of the scale. Okay, so this is a little bit more shame for this specific reason. Is clear, is colored, and all the other things are, as he was saying, positive actually of this. Any other comments on this? Yes?
Too many buttons, too many values.
Too many values, yeah, one can say 1 to 5 or 1 to 7. But with less button, they couldn't have all these red faces, probably. Like on 5, you have a limited number of negative expression to use, okay? Which reinforce the bad example. Okay, so let's move to the actual lecture. That is about principle of design, like this one that we've just said. So we already. So this picture, what this picture say? This picture say that to build successful user interface, you have 4 pillars. 4 pillars in general that stand on academic research, on academic results, and then build up to the practice. We already done 1 pillar, which the need finding one. Here is said ethnographic observation, that is one kind of observation, and user interface requirements, that is sort of what you did in assignment 1, in generating a solution, in extracting needs, in understanding things. Then the second pillar is about theories, model, guidelines, processes, etc. And we will start talking about this pillar today, especially for the guidelines, documents, and processes. Then we will meet the third pillar when we talk about prototype and tools to create them in the future. And the fourth pillar is about evaluation, where we will not talk about control experiment, but we'll talk about expert reviews, the heuristic evaluation we mentioned already, and usability testing. That will be at the end, the last topic of the course and part of the last assignment. And in this lecture about design principle, we will actually talk about these second pillars, about theories, models, because principles start from theories and generate guidelines and design patterns that we will dedicate a lecture in a few weeks. But also, those principles, those guidelines are also used for, not only for designing things as we are going to do, but also to test things, to do the expert review of things. So the expert evaluation, the heuristic evaluation, will be an evaluation that you will do according to some principles, according to some rules that an expert can use to review and evaluate a user interface. So what we start to do today, before moving to a low fidelity prototype, is to present principles and then guidelines, etc., that from one side will help you to design your first prototype, but also in the future to evaluate it according to similar principles. And today I'm going to present some of these principles, and then we will see a different set of principles for the heuristic evaluation. Today we are going to present principles that are a little bit more generic, some overlaps with the one for heuristic evaluation as well, and there will be plenty of examples to understand how they are put in practice. A lot of bad examples, some positive examples, but the goal for today is to think of this principle as a way to generate design solutions, because in assignment 2 you will need to design 2 user interfaces of your solution that you are finish up in these days for assignment 1. Okay, so the goal for today is this one, and then I will said you can also use principle to evaluate, but that will be something we will discuss in a few weeks. So when we talk about generating design solution, we have 3 levels. On the one side, we have theories. Theories are general and abstract. They tell us how things work and why things work in a certain way. On the other side of these 2 triangles, you have guidelines. Guidelines are advice, low-level advice, focused on specific cases and extremely practical and operational. In the middle, so something that is still general but not as general as theory, and something that's still abstract but not as a theory, so something that starts to be practical, something in the middle of these, there are principles. Principles are strategies or rules to analyze, to think of alternatives in design, in designing user interface, in designing interactive system, from the interface perspective especially. And we already met a theory in the very first Monday of this class. Which could be the theory that we met? It was 3 months ago, not 3 years ago. When we talk about doors, opening doors,
Don't remember the name.
what was that theory doing?
The formulation of the thought and
Yes,
it was the execution.
that one. Norman's model. That's a theory, it's general, it's play how we operate, how humans operate with any piece of thing. It's a theory, it's totally abstract, it's generic, can apply to doors, can apply to buttons, can apply to website, mobile application, is absolutely generic, abstract, and theoretical as a theory. Do you ever met a guideline? Not in this course, in general. Do you ever met a guideline? What could be a guideline? That's practical and specific case.
Yes, assignment where you say on
No.
slides there are
Someone else said something.
The emergency plan on the plane.
No. Let's think about technology. It's fine. No, not a tutorial. sort of, similar to, but it's not a tutorial. Could be in the same website where you have tutorials, you also have.
Best practices?
Yes, sort of best practices, or like how you do, how you do things. So guidelines for the web. What could a guidelines for a web application say in terms of interfaces, for instance? Or a guideline for an Android application, what would say? Where to put the buttons, which are the colors, if the navigation on the top on the button, if there are specific fonts in the visual design part, which are the rules for accessibility on the web. These are guidelines. And the guidelines for the web is for the web, will not apply entirely on the mobile because there are two different set of guidelines. So these are low-level advice. Could be best practice, could be similar to tutorials, because of course tutorial takes from guidelines. So we today will focus a little bit on theories and a consistent part on principles. We will not talk about guidelines today. We will talk about guidelines when we'll also talk about design principles closer to assignment 4 and 5, because that's where you need like colors, and you need this specific advice on to implement something in a more specific way. So theories, very briefly on theories. We already met, well, there are various types of theories. There are theories that are descriptive, so describe how things work, which is the semantic of a button, which are the elements you can use, etc. There are theories that are explanatory, prescriptive, and predictive, where you explain something, you prescribe something, or you predict that if you do something like this, then something will happen. And theories are most of the time linked to human capacity in terms of motor, sensorial, and cognitive capabilities. So skill in pointing, clicking, so movements, perceptual, what we see, what we hear, etc., and cognitive, including short and long-term memory. So one theory we already seen is Norman's model. Here is in the expanded version, and this is an explanatory theory. It explains how things work. It's not prescriptive, it's not descriptive, it doesn't describe anything specific. It explains when we interact with something, there are the task language, the core language, the gulf of execution, etc., etc., etc. It explains what's happened. And we covered this already, so let me move on. A prescriptive theory is instead the consistency theory. There's a set of theory that say that consistency is generally good. And consistency could be consistency of color, of layout, of icons, on font size, on button size, etc. And consistency could be also noun and verbs, objects and action. Because consistency within an application or across a family of application reduces learning time and error. So if for deleting or inserting a character, a word, a line, a paragraph, you always say delete and insert, that's consistent and easier to learn instead of saying delete, insert character, and remove and add word. So consistency in labels present in the user interface, for instance, or in the documentation. And we have already seen an example, I think, of something that was too consistent in one of the Hall of Fame or Shame we did so far. So these are consistency theory. Consistency is a big part in also principles. There are a lot of principles of being consistent. And inconsistency must be used in a limited number of cases to drawing attention, because we like consistency, and when there is something consistent, we just notice it out of what happens. So if there is too many inconsistent, we are always alerted or something that happens. The human processor model is another theory about the cognitive model. It's a simple theory from 1983, so it's not really recent, but it's used to calculate if you need to know how much time an operation will, on average, take, you can use the human processor model to calculate the time. So differently from the other, this is more specific. This is like numbers, calculation. So the human processor model say in a simplified way that when you like see something on screen, you have a unit that is the perceptual processor that on average takes 100 milliseconds to get the information. And then from both the eyes and the ear, and then according to which kind of information you get, if it's visual, if it's auditory, there is other times for storing them in the working memory, and after a while it is in working memory, it can go in the long-term memory. And then to retrieve information in the working memory, there are other timing to do that, and then when you need to get something, an additional information from the working memory, it goes in a cognitive processor that has other 70 on average millisecond, and instead what you see or what you hear needs an action, needs to do all this path and then go to the motor processor that has another 70 second on average millisecond. So if you need to do something really, really fast, you cannot go faster than the shortest path here. Because the human being will not be able to do things faster than that. And this is, well, this is underlines other usability techniques more advanced that represent how we operate with the technology, like these two mentioned here that we are not going to see in this course, but exist, GOMS and KLM. And this model is also used to determine the probability that a person remember an item encountered during a task, maybe a task split on multiple pages, multiple pieces of information in an application. And it also tells us, again, how long we take to do things and how long maybe a warning or an element, a transition, makes sense to show a transition from waiting or not waiting, because if it's so fast, we cannot really do the entire path. It doesn't make sense to show a progress bar, for instance, if the waiting is too short, according to this model. And we will see some example of the results of the application of this model on some of these criteria. So for what concerns memory, one thing to keep in mind, because it could be helpful, is that we have two kinds of memory, more or less. One is the working memory, one is the long-term memory. The working memory works in small capacity, and more or less we remember for a short amount of time 7 plus minus 2 chunk of information, which means that if I show you this number here, or if you show you this number here, which is the same but with spaces, it's for us easier to remember this because it's split in chunk. It's plus 39, 347, 581, 2632. It's split in chunk of information, and for us it's easier to remember a number split in this way than not the entire sequence. Same for letters. Same for all the things. If things are split in 7 plus minus 2 chunk of information, it's for us easier to remember in short term this information with respect to one long chunk of information like this number and this other letter, sequence of letter. Working memory has a very rapid access, around 70 milliseconds, so we are very fast in accesses, but also decay in 200 milliseconds. So if we have a task for which we need to remember one thing from one page to another, that things to remember cannot be kept longer than 200 milliseconds. We cannot have a task that lasts 1 second and needing to remember things because we won't remember things. So indeed, one principle is recognition and not recall of information, just for this reason. We can also pass things in the long-term memory that is almost unlimited. but it has a slower access time than the short-term memory and with a little decay over time. So no decay, no fast decay as in the working memory. These are theories that stand behind principles. Some of them we are going to see. The last theory that I want to tell you about is actually a law. It's a mathematical law that is widely used in human-computer interaction, and is the law that stands behind all the point-and-click interface, so all the desktop computer you have. That is Fitts law. Fitts law is a formula. You can compute it. But the formula, you can have a demonstration there. The formula says that the amount of time required for a person to move a pointer, whatever it is a pointer, to a target area is a function of the distance of the target divided by the size of the target itself. So the longer the distance and the smaller the target, the more we take. The more times we take, the more difficult it will be. If you need to move from here to here and click a small button, that will be longer for me to do and more difficult for me to do. Instead, if I need to move from here to here, and here there is a large button, that will be faster, quicker, less error, etc. And well, this was created by psychologists in 1955 for whatever pointer system, not necessarily a computer and a mouse, and is still used today. It actually influenced the convention of making buttons, especially on finger-operated device like a smartphone, larger than one on a desktop computer, because the pointer that is the finger is larger than a mouse pointer. And also inform principle that say that the distance between the area where the attention is, where the task is doing on a user interface, and the button, the action, the things on the screen that is for the task should be as short as possible, more or less in the same area, not sparse on screen. So again, theory, this applies to whatever pointer, whatever distance you have. If you have these properties, but it had a practical impact on how operating system and software applications are designed nowadays, and also tell us a principle to this. If I'm looking at a portion of a screen, all the elements in that portion of the screen should be around that portion of the screen, not on the other side of the screen for no reason. So keep logical element together. Okay, so theories, as I was saying, general, wider applicable, abstract, because here it talks about a pointer, about memory, about cognitive processes, not really practical. But let's move to principles that are instead the what we need to do, especially when creating a design. As I was saying before, with respect to guidelines, they are more, they are a little bit more abstract, but more practical than theories. And what we are going to talk about are the 5 primary interaction styles very, very quickly, and then 8 rules of interface design. It is a set of principles, and then we will see another set of principles when we talk about the heuristic evaluation. So the 5 interaction styles are this one: direct evaluation, menu selection, form fill-in, common language, and natural language. And this yellow part describe advantages and disadvantages of each. What is direct manipulation? Drag and drop is an example of direct manipulation, something you manipulate directly. Menu selection?
Drop-down menu.
Yeah, more than drop-down menu. When you have a menu, that could be drop-down or not, and you select an item in a menu, and you do not need a direct manipulation. Form fill-in? Form fill-in, as the name say, forms, inserting information in a form. That is a totally different style from before. You don't have menus, you don't have direct manipulation. Command language.
Like programming language?
No, like?
Terminal prompt.
No, like the terminal prompt. So command line programs, for instance. And then natural language, that is natural language, like voice recognition, etc. And each of them has advantages, disadvantages. Like for direct manipulation is easy, because the concept of moving things on a screen is similar to the concept of grabbing things and moving on a surface, but it's a little bit harder to program than everything else. Menu selection is simple to learn, you have structure, etc. But what happens if you have 100 things to display in a menu? That's a problem. Form fill-in, you simplify data entry without any problem, but use a lot of screen space. Command language is flexible, is very adapted for power users, give you a lot of freedom to do or not to do things, but you have, for instance, to remember what you have to do, because you don't see them in screen. You have to write a command on, which is again similar in a sense to programming language as well. And then natural language is easy, because you ideally can speak, but you don't have context, you don't know what to say, so you need to learn what to say, etc., etc., etc. And we also have seen some problem with Google Home in a couple of weeks ago in Hall of Fame, Hall of Shame. From the Norman model, from normal theory, Norman also explicit some principle. So we can start see some principle. State and the action alternative should be visible. So the state of the system, which are the action you can do, should be visible. Should be a good conceptual model with a consistent system image. Interface should include good mapping between the relationships of the element on the screen, and feedback should be continuous, should be appropriate but continuous. And the failure can occur when the goal is not adequate. The system will not give you the correct goal, the idea of the correct goal. As we have seen already, you cannot find the current interface object because the label is wrong, the icon is wrong with respect to the norm. You may not know how to do something, and you may receive inappropriate feedback. So this just stems from the model we have seen and discussed a couple of weeks ago. Then Ben Shneiderman proposed instead 8 golden rules of interface design, 8 rules that you can also use in designing your prototype starting from next week. And you can see something that we already met. What we already met? Consistency. And we just met feedback. And also we met the last one? Short-term memory load. So all of these stem from some theories in the end, are just more practical. So what means strive for consistency? It means that in an interactive system, similar action, similar situation should lead to a similar set of actions. And same terminology as well. So consistency in term. In prompts, menus, help, in whatever situation. Consistency also means color, layout, capitalization, fonts, etc. So if let's say a website is a 2 pages layout, it's not that at certain points becomes a 3 column layout. If it's 2 columns, stay 2 columns. If it's orange, stay orange. If something is called delete, it's called delete. It's not that at certain points become remove. Even in a different task of the same interface, consistency. Exception should be limited and comprehensive. For some specific case where you want to highlight that something is different here. You don't want consistency because you want to pick the user attention. So if a button is called next in a form, in the next form you have, it should be also always called next, etc., etc. And if a form has two buttons, next and previous, you should always have, all the forms should always have in your interface next and previous. Consistency. And if the button are at the bottom of the screen, they should always be at the bottom of the screen. It's not at a certain point they move randomly in another form. Consistency. So try to be as consistent as possible. And here there is an example of internal consistency. I'm sorry for the ones that are not talking Italian, I will describe this. What is this? They fix it a little bit. What is this? The GTT machine to activate and recharge your ticket, your monthly subscription, whatever. What's the problem of consistency here? All the people who talk Italian and read Italian can answer. It's also highlighted.
There's no consistency.
Well, there is no consistency, of course, but why there is no consistency?
Because there's written attivatito under that.
Yes, the instruction say to enable, look for the button that say ricarica, and then press it, and then put the card close to, but there is no ricarica button, because the button is called attiva titolo, which is very different from ricarica. And also here, press the info title button, but the button is called info. And who knows why they put 4 buttons when you need 2 only. So here there is, and all of this is paper, so they just needed to like have the firmware developer talk with the printer, the person who did the graphics. So was communication problem, but this gives inconsistency. If you are in a rush, you say, okay, I need to look for the ricarica button. There is no ricarica button, so how do I do? And you can try and press things until it works. That's a solution, but still is not a good user interface. It's actually a very bad user interface, and they fix it a little bit. It's not really fixed, but it's a little bit. Oh, and then there are elevators. I love elevators. So you know how an elevator works, right? You know, okay. So when you go in an elevator, what happens? You press a button, and what is written on the button? The floor. And the floor are numbers from 0, 1, 2, 3, 4, 5. And they are ordered, right? Like 0 is, you expect 0 to be like at the bottom, and 4 on the top, and then 3, 2, 1. Okay. Here we have -1. Then these are real elevators. So someone designed this and produced this and installed this, and nobody noticed. You have -1, should be underground. Then S, semi-underground. It's not 0, but it's not -1. And then you have R, a little bit more, between 0 and 1. There is no 0, indeed. And then there is 1, 2, 3, 4, 5. So you enter in this elevator, and well, if you don't to go 4, you press 4, but otherwise, maybe you don't know, or you need to go down. Where is down? Is R, S, or -1? But you can try. You have 3 chances, and then when it's the right place, you can go out. This is wrong consistency with the user mental model of how a building is made and how an elevator should work. This is funnier. What's the problem here? Yeah, the buttons are placed in absolutely random order. Like you have 0, and then on the left you have -1, okay, fine. And then on top of 0 you have 1, and on the right you have 2. And then you have 3 and 4, and then you have 5 just in the middle. Why? -1, 2, and 3 are in this position.
Maybe sometimes you have to exit on the left.
And with 5, where do you exit? On the top? So no, it's not that reason, it's who knows why. This is better. So you have in order 1, -2, 2, -3, -4, 4, -5, 5, 6, 7, -7, 8, -8, 9, -9, 10, -10, 11, and then -11 and -12. So this building is bigger underground than after, than on top of the surface. And there is no third floor.
Also -1.
And also -1, you go -11 only, or -12. So again, if you enter this elevator, you will take a moment, say, okay, what's going on here, where they need to press. So again, these are a real example in real elevators. I can also make a picture of the elevator to go to De La Binf, which is not a similar problem, but it has one problem as well. But these are messy interface because there is no consistency with the mental model. And of course, in a user interface, you don't do something like this, but you should keep in mind that consistency, also with what the reality of how things work, is important, and you have to depict it. Because someone designed this, someone created this, someone deployed it, someone paid for it, like the building manager. So this was people's work, exactly as user interface people do software engineering, developer do some kind of works. And we will also have an elevator in a future Hall of Fame, Hall of Shame, but not this kind, a more modern elevator. Okay, so consistency with mental models. And then there is consistency of operator. If you see this for the first time, this button, which is the selected one, later or now? Are you sure? Maybe not. It depends, because colors in this case are ambiguous. And if you just see, maybe all the website is white, and so you understand that you have a single button that is white, so you know that is later, maybe it's not, maybe it's now. So just looking at that, colors are ambiguous, and you have no internal queue and no external queue. In addition, when you click now, is like the current status. So assuming that now is the selected one, I'm looking at the one that is now, or pressing now will change the order and will show me the things that are now. So it's the status I want to achieve, the enable the selected one, or the status I am in. This is a kind of problem with these double buttons. We never know if it's the status I want to achieve. It's like the microphone mute and unmute. When the microphone is unmute, it represents the status. But if you click, it changes status, become a mute. But if you press a button like OK, you go in the status. The next status is OK. So it's a different perspective. So now we are used to the microphone and the camera icon, that when you press it, you go in a different state, and you see instead the state that you are. But that's just we are used to it. It's not that they are very good in terms of consistency. Here instead there is an example of inconsistency that is used properly. Where is the inconsistency here? Which is the inconsistent part? Which is the inconsistent part? The red one, the danger zone. This is inconsistent because everything else is like green. Also buttons are green and black. But here you have a red border and button red and gray. So you have inconsistent. This is from the setting of GitHub. So if you scroll, you see a lot of this. And then at a certain point, you draw an inconsistency. And this is for getting the attention of the person, that if you scroll, you always see things that are similar, and at a certain point there is something not similar, something different, and that is the inconsistency that is there to highlight that there is something to pay attention of. So inconsistency are not bad per se, but needs to be used with purpose. So in this case, to draw attention on something that otherwise is not. Okay, second rule, cater to universal usability. Users have different needs, you should know now. Let the interface adapt, let content be transformed. And this difference could be novices versus expert. First-timer user or people that use the interface for 3 years. Both should be able to use it. Web versus mobile. That's a case in which a web application adapt to suit the mobile screen. A user with disabilities as well. They should be able to use the application as a person without disability. But also international cultural variation impact the adaptation of a user interface. Which example you can think of from an international variation perspective?
Left to right to left.
Languages, yes. Languages that are read left to right or right to left. And it's not just a way of translating language, you have to shift the element of user interface. So if a button is on the left, it should go on the right and vice versa. Because different convention, and it's the same interface that should adapt. So if you're doing something for Italians in Italy, in Italian, that maybe is fine, but if you want to reach a wider audience, you have to pick in not only this kind of aspect, but also cultural elements. Not assuming that our culture in how we use an interface, how we use words in an interface is the only one, or the Western country culture is the only one, but there is adaptation in nouns, verbs, words, action, sequences that are different in different places. Expectations are different. So universal usability. Offer informative feedback. So for every, all of them, human action, there should be a feedback. In an appropriate way. It's not that every time I press a button, a pop-ups appear and say, you're sure. No. So for frequent and minor action, the feedback should be light. When you have an input field and you click on it, what happens? Not you. What happens? You have an input field, you click on it to write something. What happens?
Keyboard pops up.
What? Well, on mobile, on a desktop computer.
Like example, if you click on a button, the background color of that button changes.
They change the background, or the border change, become with a focus. So it becomes blue, for instance. That's a light feedback, because it's an action that is frequent every time you click on an input text, and minor. Infrequent and major action, a stronger feedback. So you insert something, you need, and the system need 5 seconds to process information and give you an answer, which is the feedback you provide in that moment. Loading, a progress bar, something to give the sense that something is happening, is not stuck for 5 seconds. Because 5 seconds for the human model is a long time. So frequent and minor action in the order of milliseconds are something we don't really perceive too much. So it doesn't make sense to say waiting or redraw a user interface entirely for 100 milliseconds. But if something that lasts seconds, half seconds, something we perceive, and we don't want to give the idea that it's stuck, and we don't want the person to refresh, close the app, restart again, etc. So we need a feedback. But every action should have one kind of feedback. And visual presentation of the object helps showing the changes, like it's a light, it's grayed out if something is disabled, etc. Every piece of information is a feedback. This is an example of a terrible feedback. So what is this? Yeah. What does it say, the error message? Can someone translate in English? Problems in sending the message -1. Is that helpful? No. Does it tell you something to do after? No. There is an error. So this is the error that you had, I had, teachers had, when sometimes try to send an email to students, and there are some errors, and you receive problems in sending the message, -1. How we can improve this error message? The reason is better than this, but it's not really helpful to me. Only know that there is a problem with the database. That's the reason. What I can do?
Maybe a retry button. Try again.
Which kind of message you can give to a user in this case? Try later. Better than nothing. So here you should state which is the problem. I cannot send a message for a technical issue. Try in 5 minutes, 10 minutes, tomorrow, or we open automatically a ticket and we will send you an email because I'm logged in. You send you an email when it's done. Give indication of what to do. Because here I press close and I try again in 1 second, just to see if I'm lucky. I try tomorrow, I try in 5 minutes, I just don't send a message. What I need to do is not tell me here. So feedback is important. Actionable feedback is important, is more important. This is instead a positive example. What is happening here? This is in English, so everyone should understand. A voice that didn't hear in the last 5 minutes. What's happening here? It's also written.
Like information gives before you're doing your action.
More or less. I have the Visual Studio Code set up on Windows, the file, and I want to install it for all users on a computer, so as an administrator. And if you do that, instead of proceeding and trying, it tells you a message that is a better message than error in sending the message -1, that say this installer is not meant to be run as administrator. Problem. If you want to install Visual Studio Code for all users in the system, solutions, download the system installer instead from link. Are you sure you want to continue? At that point, you can go on the website and download the system installer, or say, okay, I'm fine not installing it for all the users, not administrator, just for my user on my computer, and install it as a normal users. But it gives you which is the problem, it gives you the solution, and it gives you a path forward if you don't like the solution, that is installing it as a regular, not administration user. because they decided to have two separate installers for whatever reasons. But that's a good feedback to give, because it's precise and give you all the information you need. Then, fourth rule, design dialog hide closure. Every sequence of action should, yes?
So what happens when you click OK?
It's installed as normal user. I think, I don't have a Windows machine, so
So it's not.
it should be like that. Every sequence of action should have a beginning, a development, and end, unsurprisingly, but this is not what happens most of the time. And always provide clear feedback at the end, both to satisfy the user and to delete the current task for the working memory. So everything is done, everything is saved, the form is submitted, the email is sent, whatever happens. So here is an example for benefit from Ediso for students, where there is not a clear dialog sequence. What's the problem here? So the text say, you get enrolled in academic year 2017-2018, and you are asking for Ediso benefit for the 70th semester. At that point, you can also add a request for the first year of master degree. Are you interested? Yes, no. What happens if I press yes or no? But imagine that you are interested. What happens if I press yes or no? We don't know. I can press yes. No, but more importantly, I can press yes and this page disappear. And so what if I made an error and I should have pressed no? This is in a form, because you see the request will expire in days and there is an ID of a student, etc. And there is no next or previous. So I press yes and is automatically confirmed, or I press yes and something will appear, etc. We don't know. So this is not a clear dialog sequence, because you have to imagine and hope what happens next. So here, okay, submit, confirm, next. There is a need of some buttons somewhere to confirm the operation, because otherwise you don't know, and you can also create problem and delay in processing of the request, etc., etc. Which is linked to prevent errors. So errors will happen. You have to give feedback, etc., but most of the time makes sense to avoid the possibility to make errors. So you can disable menu items, you can disable things that are not applicable, you can prevent entering illegal character. If a field is only for numbers, just type number. Offer simple, constructive, specific instruction for recovery, and errors should never alter the application state, or if it does, it should be easy to restore the previous working state. And here there is an example of error prevention that is missing. This is to log in to a reserved area and say, warning, if the username is a fiscal code, fiscal task code, insert it with capital letters. So here there are two problems, which are well, the first one is if the username is a fiscal task code, enter it with capital letter. Is not there a JavaScript function or whatever programming language function that given a text transform in capital letter? Yes. So why you are asking the people to do it capital? Just transform it. Even better, if it's just for a fiscal code, why not checking if it's a valid fiscal code in the format? And then there is another question here. The sentence says, if the username is a fiscal code. So, if not, who knows? What could be? And if you don't remember, It's an email, is, and then there is this press here with here capital for no reason. Also, do not make links of one word, always more than one word. And then if you are an health professionist, sign up. And if you are not, you don't access the system. So it's confusing, and it's also full of errors because I can click things here and there and generate requests, generate tickets, generate phone calls just to log in. So there is a human impact after this. Permit easy reversal of action. So action should be reversible because it relieves anxiety and encourage exploration. It's not that I click there and everything is permanently fixed. And there could be different level of reversibility, a single action like undo in a word processor, a data entry task, previous and next, or a complete group of action, like I delete the form I just submitted, the information just deleted before processing to the next stage. Keep user in control. The interface should always respond to user action, never be stuck. Minimize the tedious and lengthy task, avoid surprises or changes in familiar behavior, and provides undo and redo, easy reversal of control, but also cancel, confirm. And here there is an example of here, what's the problem here, independently. So this was a questionnaire of end of course for teachers. Let's say as teacher, which problem do you have in doing the exams? And the first option was I didn't have problem, and the second option was exam organization. I don't have hardware, software appropriate, connection is low, etc. So what's the problem here? I can check I didn't have problem, and I also had other problems. So this answer is meaningless. I actually checked in this moment. I didn't have, and the organization of the exam was a problem. So this creates not only issue in filling up this, but also issue in the person who needs to analyze this data. Because this person, did it have problem or not? Was there mistakes or not? You have to get this data and throw it away because it's meaningless. And this is another example from Politecnico website, of course. There will be many. I'm happy to be in this university because it provides me a lot of screenshots for this course. Reduce short-term memory load. As we said, rule of thumb, people can remember 7 plus minus 2 chunks of information, so don't give more things to remember than 5, 7. Information on a screen should not be needed in the next screen. So if you have information in a page of a screen, you shouldn't remember it in the next screen. When possible, phone numbers, website location, etc. should be automatically retrieved from the contact app, from the GPS, from whatever. And here, I just said, information on a screen should not be needed in the next screen. And here we have an example of Google that asks username in a screen to log in, and then the password in a different screen. So apparently it goes against these rules, but in practice is needed, and it's not a terrible idea in this case. Why?
Did they mention the email?
Yeah, they mentioned the email in the second one, but why don't put two input text here?
Because you can access in more ways, not only password. You can use the phone, you can use the passkey.
But that's, yeah, that could be maybe, but you can have like email and then a drop down that say select the method you want to proceed with, and so.
Since I use this system, it remembers different emails, and in this next step you can change the email.
Yeah, almost. Is linked to that. Why does it remember multiple emails?
If you have a work email, then it will be redirected to another.
Yes.
page.
Because this page is used to understand if you want to log in to Gmail or you want to log in to the Google for working at your work company. So the page is the same, and then according to the domain that you're using it, it will redirect to Gmail password entry that will verify on the Google server, or the Polito, let's say, is not, but let's imagine that we use Google instead of Microsoft. It will redirect to the Polito website to check with the password on Polito system and not on Google server. So this is also needed for doing this separation. Otherwise, it would be much more complicated to enter in a single form, also for the user perspective. And of course, sometimes entering is better than selecting. So here is an example in which you have to select which score, which exam and which score you have. And of course, for an English exam, and of course, this list is endless because they have one item, so you have to select this. So this could be like entering, auto-completion, or to separate first, you select the certificate and then you enter the score, etc. So this is an endless list from Politecnico website as well, a few years ago. I hope that it's improved now. Then there are, here in the slides, there are other design principles, but more or less they overlaps. So Benyon would say that there is learnability as a principle that brings with them visibility of the system state, we already said, consistency above familiarity, recognition, affordance, we already talked about affordance a couple of weeks ago, effectiveness in terms of feedback, again, navigation, maps, signs, etc., and control. Who is in control? And we already had a principle from before. And here there is another example of a navigation control in which you don't really understand what to click. Should I click? What happens if I click confirm? Then I have to click next. And if I click next, can I go back here and confirm? And again, similar to the previous case, there is a little bit of confusion in navigation and control in this case. Safety, again, recovering constraint as before, and accommodation, flexibility, universal usability. You see there are overlaps between these principles as well. And here there are another set of principles of interaction design. Again, consistency, efficiency, learnability, simplicity, etc. That if you want, you can expand a little bit on your own if you want, but the idea is that you have principle. Let's use the Schneiderman 8 golden rule as a reference that you can use when you are designing a form. Are you putting all the information in one screen? I'm putting the button in this way or not, and I've seen it in project in this course. So pay attention, etc., or not. So use this principle and the example was seen to not do the same errors as they do, and to do better job with these 8 principles for when next week you will need to design your low fidelity prototype. Okay? Any questions? Okay, so we can do 10 minutes break and then start with an exercise on task and storyboard that will be needed for assignment 2 next week.